Now, last time we have studied that if a function is continuous that at a point C, then it is differentiable at a point C. We will do the reverse one. If a function, if if fx is differentiable at a point C, then it is also continuous at that point. So we will be proving that. Now f dash x, that is f dash x is equal, that is f dash c means we will is equal to fx minus fc divided by x minus c, comma x not equal to c. Okay, why x not equal to c? Because if x is equal to c, then it is 0. 0 doesn't have any meaning here because it is not divisible. Okay, so we will start the proof. Now fx minus fc is equal to, I can write fx minus fc divided by x minus c into x minus c, because these two will be cancelled. Okay, now I take limit for both the sides. Limit x tends to c, fx minus fc is equal to limit x tends to c, fx minus fc divided by x minus c into x minus c, the whole thing. Okay, now I separate these two. This will be, that is equal to limit x tends to c, fx minus fc divided by x minus c into limit, because limit f into g is equal to limit f into limit g. So limit x tends to c, x minus c. If I put, it is tending towards c, so if I put x is c, then it will be 0. So that is equal to limit x tends to c, fx minus fc divided by x minus c into 0. The whole thing becomes 0. So I have put x is equal to c, so this is becoming 0. Now here, limit, we know limit x tends to c, fx, and limit x tends to c, fc will be fc only. Fc is equal to 0. This is, I'll write limit x tends to c, fx is equal to minus fc, because it's okay, that is equal to 0. So implies here limit x tends to c, fx is equal to fc. That means, what is this? What does it mean? It means the functional value. It means the functional value is equal to the limiting value. It means the functional value is equal to the limiting value. Implies fx is continuous. at x is equal to c. Okay, so at x is equal to c. So first theorem says that if x is if it is continuous at x is equal to c, it is differentiable at x is equal to c. Now we will say the second theorem says that if fx is differentiable at point c, then it is continuous at the points at that point. Okay, now f dash c is equal to the we know the sorry here it will be limit x tends to c is equal to limit x tends to c is equal to fx minus fc is f minus c is f x not equal to 0. So we will just write fx minus fc, and this is the division here, and I'm dividing and multiplying so that it gets cancelled. Then I take the limiting value of this and limiting value of this. This becomes 0. 0 multiplied by anything is 0. So fx limit x tends to c, fx minus fc is equal to 0. Is equal to 0. Therefore, limiting value is equal to the function value. When it happens when the function is continuous at x is equal to c. Find the derivative of, now we are doing the sums, derivative of x raised to the power 3 by 2, so on. I have given all four sums. That is 1, x raised to the power 3 by 2. So I will write let fx is equal to, therefore, ddx of fx, that is derivative of fx, will be ddx of x raised to the power 3 by 2. Okay, x raised to the power 3 by 2. This I'll put it in the bracket. So what is the rule of that? It reduces 1 degree here. So we will write, that is because this is just preliminary, we will write 3 by 2 into x raised to the power 3 by 2 minus 1. That is equal to 3 by 2 x raised to the power half. This is the answer. Okay, this is the answer. Now, then second part, have you followed all of you? Yes. Second part is that let fx is equal to, we will write fx is equal to root of x. That is equal to, therefore, ddx of root of x. I can write ddx of x raised to the power half. That is equal to ddx of ddx. So we will just reduce the 1. First I will come, I'll bring the power in front, then x raised to the power 1 half minus 1, that is equal to half x raised to the power minus half. It's okay. X raised to the power minus half is that equal to 1 by 2 root of x. Yes, 1 by 2 root of x. It is answer. Then third, now let fx is equal to, third is that let fx is equal to 1 by x. X, that is let fx is equal to, that is equal to x raised to the power minus 1. Therefore, ddx of fx is equal to ddx of x raised to the power minus 1, that is equal to minus 1 will come in front, and x raised to the power minus 1 1 and minus 1, that is equal to minus 1 x raised to the power minus 2, that is equal to minus 1 by x square. This we will do orally after some time. Then the fourth part says that is 1 by root 2 x. Yeah, that is let fx is equal to, we will write, let fx is equal to 1 by root 2 x. Root 2 x can be written as, that is root 2 will be the, here it is constant, 1 by root 2 we will write here like this, and x raised to the power minus half. Yes, x raised to the power minus half. So there is equal to 1 by root of x raised to the power minus half minus 1, that is equal to 1 by 2 root 2 is x raised to the power minus 3 by 2. This is the answer. Here it is the answer. So I have done all the derivatives. These are all simple form of it. Okay. Then next lecture I will doing little complicated one.